Now,
No,
if the test is going to be like this, it would be super easy.
I suppose this is there are no
Yeah,
secret. And my test never we have secret. Exactly same.
right.
No, no
Oh, no
secret, no
secret. No.
sophisticated question. A regular question. So you follow me, you have no problem. This is the
Okay.
answer now. The answer is a quotient, que is the expression in here. Any question? No, no, no. Okay, let's practice now factorization. Factorization is that I go to the worksheet 10. Worksheet 10. Test 3, worksheet 10. Okay. Number one problem is, okay, number one problem is, number one, I copy, xy minus a yz plus 10 x minus 80c. Okay. So immediately I realize guess grouping. How do you know guess grouping? What is the clue? Que give me information that we are doing factorization by grouping. 1, 2, 3, 4. When the 4 is grouping, always. And you try to do your best. What is the GCF in the first couple? What is the GCF and the blue couple? The way they are present. The way they are present. What do you say? They are present. What is the GCF in the first couple? What is the B? What?
Why?
Y factorial y. We have x minus az. What is the GCF in the second?
Isn't it 10?
10.
It's 10. You are right, mister. So x minus az. So now I can see que x minus az is common factor. I factor out one more time. Open new parenthesis. Inside the new parenthesis, we have that y and that 10. Y plus 10. End the story. I finish. Factorization grouping by grouping. Any question? No?
No, that one was easy.
Absolutely. AB plus 11A minus 5B minus 55. Again, I realize guess grouping. Well, the glue guess grouping is because it's 4 terms. Si es 3 term, trinomial. Si es 2 term, binomial. 4 term, polynomial. Grouping. GCF in the first couple and GCF in the second. GCF in the first is, I need help. I cannot do by myself. A. Good. B plus 11. What is the GCF in the first and the second? 5 or negative 5?
Negative 5.
Negative 5 much better. So negative 5 out, B plus 11. This is 55. And B plus 11, I can see it's a common factor. Open the last parenthesis, A minus 5. Final answer. Any question? It's clear? Okay, let's go. Let's go. Let's go to the part you like so much. Trinomial part. Trinomial part. This is x squared plus 3x minus 54. This is regular, complicated, or perfect square. Classification, trinomial. 3 term. Irregular, very well. Irregular. Entonces, si no es de regular, automatically, I open two parentheses, I put the key open the door. The key open the door, 54, I need to find two factors que somehow multiply each other, give me 54, and somehow...
9 times 6.
Excellent, 9 times 6. Okay, now adjust the sign. What about the sign? Different sign, same sign, positive, negative, what is positive, what is negative? Different sign. I agree, because the clue can indicate a different scientists.
It's positive 9 and negative 6? Question mark? I don't know.
Who is positive?
9.
9. And 6 is negative because it's different, right? Just in case, I FOIL to verification. Multiplication, x times x, x squared. X times minus 6, minus 6. 9 times x, plus 9. And this, 54, negative 54. When you combine like term, this and this, it's 3x. Exactly like the original trinomial. And then the answer is this. Guys, mandatory verification on the trinomial, because sometimes it's very confusing. Sometimes you believe that you get and no, you don't. Okay, number 4. Any question? Any question? Everyone follow me?
Yes.
What do you think about this trinomial? What do you think about this trinomial? It's trinomial, right? Trinomial, 3 term, 1, 2, 3. This is regular, complicated, perfect square, blah, 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 blah. I don't know. Complicated. Noela, you are a complicated girl.
I know that 5 times 3 is 15, and also 15
Exactly.
plus 3 is 18.
Exactly.
That's all I see. But then when it comes to positive and negative, and then I have to think about it.
Okay, wait. The methodology to do the factorization is always the same, and the student normally forgot. The first thing you should do is GCF. We have GCF here or no? What do you think? Great common factor. What is the great common factor? Yes, where's that? What is the great common factor?
3.
3. Very well. 3, do you factor out 3? So we have x squared minus 5x plus 6. Yes or no? Now I focus in the trinomial part. In the trinomial part, this trinomial is regular, not complicated. I continue to bring down this 3. It was the answer for the GCF that we are doing before. 2 steps. Step 1, great common factor when it's possible. No? And step 2, a factorization of the trinomial. What kind of trinomial? Regular. The regular, you open two parentheses, xx. Now I need to find the key to open the door. What is the key to open the door? Wow. What is the key to open the door? 2 numbers can multiply, give me 6, and somehow 2 and
2 and
3.
3.
2 and 3. 2 and 3. 3 and 2. I don't know why. I told you I like to put a bigger first. I don't know. And what about 6 and 1? 6 and 1. So 6 is 2 and 3. I agree with you. And 6 is 6 and 1. And 6 minus 1 is 5. We have 2 combinations or only 1? 3 and 2 or 6 and 1? Sometimes happen we have 2 combinations. However, only one work.
I think it's 2 and 2.
Absolutely. I want to prove that the other doesn't work. The 3 and 2 work. What sign? What sign? Help me with the just the sign. What sign? Different. Same sign. Very well. Same sign. This is a glue that give me information. The same. And
Negative.
And you multiply quickly. X and x is x squared. X times is minus 2x. Is minus 3x. And it's a plus 6. And when you combine this and this together, minus 5x like the original. Look at that. And this is the factorization. The factorization includes 1 extra 3 that we are doing after the GCF part, and break it down the trinomial to binomial. End the story. Any question? Okay.
Professor, I have a question. But Professor, I think you explain in a different way. Multiply the square, multiply the square. When it's supposed to do?
What I'm supposed to do? Okay. So you following the methodology when you face one problem of the factorization, the first thing you should do is GCF. So you forgot this because you try to do fast. Okay, you are in trouble. GCF first. When the GCF is 1, here, entonces come. Otherwise, no. You try to do your best, following the methodology. GCF first. Suppose number 5, Noela. 2x squared minus 7x minus 15. We have GCF or no? We have GCF here. No. So GCF is 1, entonces totally useless. Okay, now you realize that these two give me information that we are in front of a trinomial, and you multiply this and this, 30. I don't care this sign. This sign is not important. You multiply 2 and 15 without sign. And try to find the key to open the door. I need to find two numbers that multiply, give me 30, and somehow when you add all subtraction, give me 7. Where is the key? Where is the key to open the door? No, because 6 times 5 never gets 7. When you're adding 11, when you're subtracting 1. This is another
trial and error.
Look in the ceiling. Look in the ceiling. He has to God, give me the number, please. Here, 10 and 3, very well, 10 and 3. Because 10 times 3 is 30, 10 minus 3 is 7. Perfect. So I bring down 2x squared. I bring down 15 with the corresponding sign, of course. And you separate 7, negative 7, and 10 and 3. Of course, negative 10x plus 3x. Are you negative? Because if you combine like term, negative 10 and positive 3 is negative 7, like the original. So that the process we are doing so far is you have trinomial, and you convert to polynomial. Grouping, yeah. But the process we are doing from this to this is conversion, trinomial 1, 2, 3, and 1, 2, 3, 4. Okay, and now ready to apply grouping. Yes, GCF in the first couple and GCF in the second couple. What is the GCF in the first couple? What is the GCF in the
question?
Isn't it 1?
Isn't it 1?
GCF is 1.
GCF is 1.
No, GCF in the original was 1. But now I analyze by grouping. So by grouping, that is the reason I put color. You focus in the blue color. What is the GCF in the expression? And you ignore mentally, erase, delete in your mind 3x minus 15. You focus in 2x squared minus 10x. What is the GCF?
2. Because
Only
2
2?
times 5 is 10.
No. It's 2. I have partial agree with you. And x is no common. Yes or no?
Yeah, 2x squared.
Okay. When you find the GCF, you need to consider numerical part is 2 and the variable part x squared x is 2x. This is my GCF. I factor out, I have x minus 5. Correct? And what is the GCF in the green part?
3x.
What is the 3x?
Right.
No.
Okay.
It's just 3 because you have x here, but we have no x here. So x is no common. 3, yes, because 3 is 3, and 15 in my mind is like a 3 and 5. This 3 is common. I factor out x minus 5. Ready. X minus 5 out. One time. Open new parenthesis 2x plus 3. End the story. I want to check, of course, what I want. X 2x, x times 2x is 2x squared. X times 3 is 6. Is 6, no, it's 3. Sorry. This and this is minus 10. And this is minus 15. And when you combine this and this, so this is first, outer, inner, and last. When you combine always outer, inner together, give me the middle term. Okay, 7, like that. This factorization is good. Any question? What part you don't understand very well? The problem is remember step by step everything. GCF. When you find the GCF, you need to analyze numerical part and variable part. Okay? No? Confusing? Clear?
Clear.
Very good. Clear. Okay, 6x squared plus 17 x plus 12. GCF. We have GCF, yes or no?
No, Professor.
No. Well, actually, the correct answer is not the word no. Sino es one. One is synonymous to no. We have no common factor. Now we are in front of a complicated trinomial, no? To see you multiply this and this. 72, no? Okay, I need to find the key to open the door. The key to open the door. 2 factors of 72 que somehow give me 70. Exactly, 9 and 8. Because 9 times 8 is 72, 9 plus 8 is 17. I bring down the first, I bring down the last. I split 17 using 9 and x. In this case, both positive, right? Because addition is 17. And now we are ready to apply factorization by grouping. The GCF what is GCF in the first column?
Is it 3?
Is it 3? Yes, 3x. Remember, I repeat one more time. You analyze numerical part. Let me see. 6 and 9. 6 is 2 and 3. 9 is 3 and 3. Es obvio que 3 is a common factor. But numerical variable part, x squared. What the hell is x squared? X times x. And x alone is 1x. Oh, I saw that x is also a common factor. And the greater common factor is open parentheses 2x plus 3. And what is the GCF in the second? 4. Okay. 2x plus 3. Now 2x plus 3. Parenthesis 3x plus 4. I suppose that this is my final answer, but I want to get 100 points in this test. Yeah, verification. I multiply 4, 6x squared plus 8x plus 9. Because 3 times 3 is 9 plus 12. When you combine this and this, we get 17. Exactly the same to the original. Therefore, this factorization is perfect. Any question? Hey, noise. Hey, I hear noise. Okay, no noise, guys. Okay, putting off the microphone. Okay, number 7. Number 7. No. Number 7 is 12 x squared minus 52 x minus 40. Okay, now GCF. We have GCF, yes or no? Well, I have no idea. I suppose que you. Okay, I know. Let me try to break it down. 12 is 2, 6, 2, 3. 52 is even. You put in the calculator 52 divided by 2, 26. And 26 is 2 and 13. And 13 is prime. Stop. And 40? 40 is 220, 210, 25. Entonces I can see with my eyes what is the common factor. Well, at least 1, 2 is common. Does it? No. Another 2 is common. And no more 2 is common, right? F4. The GCF F4. Very important. Now I convert using GCF this horrible trinomial and other more nice trinomial gets 3. 3 because when you factor out 4, wait a second. When you factor out 4, you have 3x squared. Look, when you factor out these 2 and these 2 gets 4 out, stay this 3. Minus, when you factor out 4, likewise, you have 13x. And when you factor out this, stay 10, no? 10. Oh, nice. Entonces, I focus 100% to this trinomial.
Isn't it minus?
It's minus? Yeah, you're right, mister. He helped me to say it is a minus. Look, it's minus. Okay. Now, this trinomial is complicated, of course. A multiplication. This is 30. Yeah, I need to find the key to open the door. Two numbers can multiply give me 30, and somehow, adding or subtraction give me 13 is 10 and 3. 10 and 3, because 10 times 3 is 30, 10 plus 3 is 13. Okay, now copy down. I copy. Don't forget to copy. Don't forget that 4. Okay, was the first 4. Okay, we factorization. The greater common factor, the initial greater common factor. Okay, to say you copy 3x squared minus 10x minus 3x minus 10, no? It's 10, yeah, it's 10. It's 10, this 10. Okay, now grouping. GCF in the first couple, GCF in the second. SX, yeah, you're right. 4, don't forget this 4, continue, bring down. Okay, this X, we have 3x minus 10. And the great common factor, wait. Something. Wait a second, something's wrong here. Something's wrong. 5240. The great common factor is -1, no? Es -1, entonces 3x plus 10. Something's wrong. Something's wrong because I wish. Are you sure? Yes, 40.
I think it's on right below the 30.
Oh, yeah, you're right.
Parenthesis.
Yeah. This is good example. Good example que illustrate us que this combination doesn't work. So we need to find another combination. Noel, I don't know. Somebody say que 15 and 2, no? 15 and 2. Let me see. 15 times 2 is 30. And 15 minus 2 is 13. Wow, we have another combination. And see, one combination doesn't work. How do you know it doesn't work? Because when you try to use your best in factorization by grouping, this trinomial and this trinomial is completely different. And remember, I am so sad. Let me try using 15 and 2.
When you multiply the 3 times -10, isn't that a -30?
No, because, okay, you see again the green part, the great common factor is -1. I factor out negative and positive, negative and negative and positive, negative. No, this is perfect. However, in that case, I saw que x is common factor, I factor out, this is stay positive, but this is negative. And this binomial and this binomial is not the same. When this is not the same, I did something is wrong. Okay, but though, okay, I see something is wrong, I try.
Where does the negative 13 next?
Let me try. You only pay attention. Look, now, see, I select the combination 15 and 2, I copy 4 again. Okay, 4 was the answer for the GCF, no? I copy 3x squared. Now it's minus 15x plus 2x minus 10. Okay, let me see if I did well or no. 15, negative 15, and positive 2, and negative 13. Okay, this is another possibility, right? Now, again, I try to do my best. GCF and the blue part. GCF and the green part. What is the GCF and the blue part? What is it? 3x. We have x minus 5. What is the GCF and the green part? 2, right? X minus 5. Es 2. Entonces x minus 5. Wow! I compare this factor and this factor. Look at my face now. Happy. Because I almost finished. Okay, I factor out x minus 5. So this 4, you continue right. It's x minus 5. Factor out and open the last parenthesis. Inside the last parenthesis, we have 2x plus 2. Wow! And the story. I finished.
Why is
The order doesn't matter, yeah. Giancarlo, the order doesn't matter. Remember, this is factor. 3 times 5 is equal to 5 times 3. The order you write doesn't matter. Doesn't matter. It doesn't matter. It's a good example. Noela, yes, it's a good example. It's a good example. Okay. Entonces, now, don't expect...
within parentheses, like 4 parentheses, 3x, another parenthesis, x minus 5.
Another what? I don't understand.
Yeah, it's okay.
It's okay? Okay. Some people have internet problem with it. You see the echo. Pero you understand very well or no? Okay, the thing que this problem number 7 illustrate was que sometimes, not always, we have 2 combinations and only one is good. And maybe you select the wrong. Actually, I select the wrong, but in one moment I get contradiction because I cannot progressing with the factorization by grouping. Okay, let's go to number 8. Number 8 is binomial. A binomial is super easy. 16x squared minus 81. Okay, I using that formula. Okay, I using that formula. A squared minus b squared is equal a plus b, a minus b. I repeat again the idea that the order is not important in the factorization. Then you find the square root. This arrow indicates square root. A square root this is 4x. A square root this is 9. So square root 16x squared is 4x. Square root 9 is 3. And this work in my formula like a and b. Open two parentheses and you put 4x. 9, and plus or minus. It doesn't matter the order. It's the final answer. Very, very easy. I know. Very, very easy. I know. Very, very easy. And one clue can give me information that this is good is because the number involved in the problem 16 and 81 are perfect square number, no? See, the number is not perfect square. So something is wrong or I need to do extra thing. Number 9. Number 9 is 50 minus 8 squared. Entonces now es factorization. Factorization this guy. Oh, pero 50 is not perfect square. And 8 is not perfect square. So square of 50 is decimal. You put in a calculator. No, something is wrong. But you forgot again the GCF. What is the GCF? What is the GCF in this expression? What is the GCF? 2 is the GCF. Entonces you factor out. So you forgot to factor first GCF, you are in big trouble. You complicate your life. Okay? So you factor out 2, you have 25 minus 4a squared. And you focus in that part. It's obvious que es differences of the square. Square root 25, 5. The square root 4a squared is 2a plus or minus. End the story. I finish. We are the best. No problem. But don't forget GCF first. This is extremely important. And frequently, I saw every day, some people, some tutor forgot the GCF first. Number 10. 16 C4 minus D4. We applying the same formula or no? This is my formula. Let me go back to refresh my memory. And this formula is applied regardless si the exponent is 2 or f4 or f6. Si it's even number, you can apply that formula. But this is square root 16 C4 is 4C squared. And square root D4 es D squared. Ok, entonces yo separé en two paréntesis. I copy 4C squared, D 4C squared, repetition again, sorry. D squared, plus or minus. I finish. Why keep going? This is the final answer, or is it, or we gonna finish? Keep going. Why? Because you factor completed. I can see here another difference of a square. And remember, the sum of the square, que es this, is impossible to factorization anymore. So this expression is prime. So you copy. I cannot do anything more in this, but in this, yes. You separate in 2. Square root this is 2c to c. Square root this is dd plus or minus. Okay, so in this example, I apply that formula I apply 2 times. And you continue until you factor completely our expression. So our expression is totally prime. It's a combination prime factor. See, at least one factor is not prime. That is because you can break it down. Okay, the factorization you should do.
Why? I'm sorry. Why did you break it down? Because the sign.
The reason is because I can see that this expression is another difference of the square. However, this expression, no. This expression is the sum of the square. And the sum of the square, we cannot do anything. However, the difference square, yes. Actually, I did in the first step. From this to this, I apply different of a square. For this and this, I apply the same idea. I break it down. This is different because of subtraction in 2 pieces. Clear? Clear, miss?
Yes.
Absolutely. Okay, what about 11? 11 is 3x squared plus 27. Okay, well, this is confusing. What's that? GCF, we have GCF or no? What is GCF? Yes. What is the GCF in that case?
3.
3. So you factorization 3. We have x squared plus 9. And we can factorization x squared plus 9? No. Because it's the sum of the square. So we cannot factorization. And leave it like that. Final answer. Okay? This is similar, guy. When you break it down, for example, you have 21. And 21 is 3 and 7. And 7 we can break it down. No, because 7 is prime number. And likewise, x squared plus 9 is the sum of the square. Okay, I know it's prime algebraic expression. We cannot. We cannot. We cannot do anything. Okay. Let's go to the binomial again, but now using cubic. I want to recall the formula. Okay, the formula. We have two formulas. The formula for the sum are different. Both are no. Okay. A square. Okay. Repetition is prime. Is when it's subtraction is a plus b, a minus b, and the cubic when this. Let me try to do first subtraction, difference of cubic. The factorization is a minus b, a squared plus ab plus b squared. And the sum of cube is also factorial expression, is a squared minus ab plus b. A similar formula is said in the first binomial is exactly the same sign of the original, and this is always plus, and this is the first is negative, no? It's the only difference. And by the way, this trinomial and this trinomial, we cannot factorization is prime. This and this are prime. Exactly the same. This is prime. This and this together, this and this is prime. So don't try to do anything because it's possible. You waste the time. So you try to do something. Leave it like that, and that's it. Now you apply cubic root. In order to find the a and b and the formula, you take both, and you find the cubic root. A x cubed and cubic root of 27. This is 2x, and this is 3. Yes or no? Because 2 times 2 times 2 is 8, no? And 3 times 3 times 3 is 27, no? Okay, what is the idea for the cubic root? You need to find one number can multiply by itself 3 times in order to get the number inside the radical. And thus this expression working like an A and this working like a B in our formula. So you open two parentheses, one short, one long. Inside the short, you copy 2x, ux, 2x, 2x, and 3, and the sign is minus exactly like this. Now I am doing this, now a square is this expression is square, so 2x squared is 4x squared, no? Plus a and b together get multiplication, this and this is 6x plus the last one is b squared is 3 squared and 9, and it's the final answer. Any question?
Professor, our formula is negative, AB is negative.
It's negative because it's different of cubic.
Okay, so first one, sorry.
So what formula are you using? Number 1, number 2, number 3, or number 4? What formula we are using? Number 1, number 2, number 3, or number 4?
Professor.
Number 3. Yes, you are right. Number 3. Number 3. Okay. That was number 2. Any question, guys? Do you understand or no? Remember, I'm doing it too fast. Because I suppose I explain this in your moment, no? This is review. And review, I'm doing too fast. Okay. Good. Very good. 13, no? 13 now. 13 is easy. It's a to the 6th power plus 125. I suppose it's the sum of cubic. And cubic root a6 is a second divided by 6 divided by 3. And cubic root of 125 is 5. Because 5 times 5 times 5 is equal 125. Okay, so now this is my A and my B. So you separate into binomial, trinomial. The binomial is a squared minus 5. And the trinomial is 8 to the 4 power, que es the square this guy, plus, no, minus, because it's plus here. Sorry, this is plus, and this is minus. Multiplication both, que es 5a square, plus square the second, que es 25. 5 square. And this is the final answer. Any question? It's easy, eh? It's just a formula. Identification the case, apply the formula. 14. 14 is a little bit more interesting. 24 x to the 4 power minus 3 x y cubic. Oh, what the hell is that? What should I do? Help me. GCF, very well. No es la 6, GCF. Entonces no es la 6 que GCF es 3. Es only 3. No.
No, Professor.
What is the GCF? 3x. Excellent. Remember, numerical part and verbal. I discover que GCF is 3x. I factor out first. Open new parenthesis, ax cubic minus y cubic. Wow. And this inside the parenthesis is 1 difference of cubic. And the cubic root this guy is, okay, is 3x, it was the GCF. I open two parentheses, the short and the long, binomial, trinomial, and the cubic root is 2x minus y. Cubic root. And square this is 4x squared plus multiplication both 2xy plus y squared. Finish. Is the final answer. In this case, was a combination GCF first. This 3x was the answer for the GCF part. This was the GCF part. And the rest was apply the differences of the cubic. The differences of the cubic. Any question? One more. Okay. Okay. Are you happy? This is a happy face or a sad face?
Okay.
Happy face. Good. Very good. Let's do it 15. It's skeptical. Okay. Okay. K to the 5th power plus 1 over 8. K to the 2nd power. What should I do, guys? Tell me. I'm in big trouble. Okay, I am lost. Come on. What is that? GCF?
It's K.
GCF. What is that? A K? Or it's K squared?
K squared.
You take always, it's easy. GCF is super easy. You take the smaller exponent, that's it. And you factor out. You have K to the 3rd power, no? Because 3 plus 5 is 5. 3 plus 2 is 5. And 1 over 8. Now, the expression inside the parenthesis is a sum of cubic. So K squared I bring down, separate in two parentheses. This is KK. This is 1/2, no? 1/2. Because I know the cubic root. 1 over 8 is cubic root of 1. It's a fraction. This is confusing. But no, it's not confusing. Cubic root 1 is 1, and cubic root of 8 is 2. That's 1/2. A plus here. Now, square this guy. Minus, multiplication both, que es 1/2 K, plus square this, que es 1 over 4. And 1/2 square, and 1 over 4. Is it clear or confused?
I don't understand.
You understand? You understand or you don't understand?
I don't understand.
You don't. What part you don't?
When you break it down to the parentheses at the end.
Okay. So I suppose that you don't understand the second parenthesis. Yes or no?
Yeah, I don't.
Okay. Let me compare this and our formula. Our formula say a plus b, a squared minus ab plus b squared. In our example, a is k. Look at that. And b is 1/2. Entonces I just copy a and b, connecting by plus, according to the formula, ¿no? Entonces you take a square in my formula, pero es k square in our example. Minus, this minus, multiplication both. Multiplication, you can multiply k times 1/2. Pero I prefer put the coefficients in the front, 1/2 k. Plus b squared, and b squared is 1/2 square, que es 1 square over 2 square, is 1 over 4. I put 1 over 4. More clear now?
Yes.
Absolutely. Super good. Let me try to see what's the next. Yeah, absolutely. The formula is the best friend. Giancarlo say the formula is our best friend. This is the reason que the trinomial is easy. Okay. Let me try. 16 and 17. Okay, erase the board. The best friend again. Okay, 16 and 17 is a classical example. Okay, let me copy both simultaneously because it's same objective, same idea. 9x squared minus 12x plus 4. Okay, I have no idea. 25x squared plus 20xy plus 4 y squared. Okay, what's the mistake, the frequently mistake? The student believe que this is a complicated trinomial. Too complicated. Mira, no era believe que es complicated. Y actually, the answer is yes, pero the answer is no. Because you are doing under the consideration que es complicated, you complicate your life. However, si you believe or you realize que this is perfect square trinomial, wow, it's super easy. And what is the test to prove que es perfect square trinomial? Well, in the first place, 9 and 4 are perfect square number, right? This is one clue. Si es another number que es no 9, 4, 16, 25, 36, entonces no. Of course, it's complicated. But I take advantage. Okay, 12 is not. No. The first and the last and the middle, no important. O sea, the first and the last, I don't care. The middle, you see now. Remember, perfect square is a plus b squared is equal a squared plus twice ab plus b squared. This is the formula for the perfect square. But don't care for the formula. Look, this is the square root of this guy is 3x. The square root of this guy is 2. And when you multiply 3 times 2 times extra additional 2, why additional? I explained several times. This 2. 2 times 2, is 4 times 3 is 12. And you get suddenly the middle term. I don't care the sign. The sign is not important. Multiplication this, multiplication this, multiplication this. This is the test que give me information que this trinomial que we are solving now is perfect square. And si es perfect square, the factorization is too easy. Only you copy this guy, only you copy this guy, 3x minus 2, y minus because it's minus here, and you square. Because they are two twins, binomial. You can write like that. But you know, when it's repeated, you put a square. This is the super elegant final answer. Okay? Okay? Listen to me. Listen to me. You face one trinomial. You don't know si it's regular, si it's complicated, or it's perfect. Now, si it's regular, everyone knows.
Professor,
Uh-huh.
be positive. One of them will be positive, right?
No, always is negative because this sign is negative. And this sign always must be positive. See, this sign is not positive, so we are in big trouble. This is no perfect square. So perfect square, regardless, the sign is a square minus twice ab plus b squared. The sign is always positive. And making sense because they are twin brother. It's the same sign. Same sign. Okay, it's obvious. Okay, the first sign is positive and the perfect square. So you see que es negative. No. Entonces this is no perfect square. This is maybe it's complicated trinomial. Maybe. But I need to identification when it's perfect square. I know normally when they teaching this several times every semester, the student forgot this idea. Okay? I don't know why, but I forgot. Well. Entonces now the second 17 is another typical example because the clue 25 and 4 are perfect square number, and the square root this guy is 5x, and the square root this guy is 2y. And when you multiply 5x times 2y times additional 2, do you understand where I come from? The additional 2, you get 20xy. It's exactly the same of the middle term. Now the factorization, this is extremely easy. You copy 5x, is this guy. You copy 2y, is this guy. And the sign positive here because this sign is positive. And this sign always must be positive. And this is the factorization. End the story. Clear or confusing? Guys, the problem is, the problem is your big trouble is that you forgot. I explained the thing. I don't know, in your mind, you don't organize very well, or you take, maybe you are taking 4 classes, but if you don't remember, we are doing nothing. Okay, let's move on to the 18. 18 is 2m squared minus 18. Okay, yeah, la quicha. Help me. I need help. What should I do? Factorization this. Factor the polynomial completely. What should I do?
We have to.
Wow, I don't understand anything. I suppose that you say GCF, no? What is GCF?
2, Professor.
2 m squared minus 9. I stop or continue?
You can continue.
Of course you continue, because I can see clear like water, okay, this is the difference of a square. And the factorization is 2m plus 3 m minus 3. It's the difference of a square. And this is my final answer. Now, it's a miscellaneous problem, and we apply several techniques of factorization. GCF is the first. And the second depends si es binomial, si the exponent is 2, si the exponent is 3, I don't know. 19. 19 is 10y squared plus 3y minus 4. Okay, where's the GCF in that case? We have GCF or no? No, no, yes, no, no. No GCF?
No.
No. Okay, and the 10 and, well, 4 is perfect square, but then no, there's no perfect square. It's impossible to be. Entonces this we are in front the complicated triangle. A multiplication of 40. Now find the key to open the door. What is the key to open the door to number two factor of 40 que somehow when you adding or subtracting give me 3. You see or you don't see? No?
I'm trying.
Okay, no, but okay, you try. How you try? Look in the ceiling. God, give me the number. No, you in one corner of the piece of paper you write 40. And 5 and 8, yeah, 8 and 5. That depends on your skill in arithmetic. But if you don't have a skill of arithmetic, you take your own calculator. Entonces I need help. Okay, you copy 40 times 1. 20 times 2 and so on, no? And maybe you spend 1 week doing that, but you get the answer, 8 and 5. Another possibility is 10 and 4, and by 3, no, by 5, yes, 8 and 5, I got it. 8 minus 5, 3, okay. So you bring down 10 y squared, and you separate 8 and 5. And the corresponding sign, positive and negative. Because when you combine like term, positive 8 and negative 3 is positive 3. I'm ready to apply factorization by grouping the blue and the green. What is the ECF and the blue bar? 2y. Very well. We have 5y plus 4. What is the ECF and the green part?
We don't have.
Yeah, we have negative 1. You see negative. Negative 1. Entonces 5y plus 4. Entonces 5y plus 4. Open the last parenthesis, 2y minus 1. Final answer. Okay. It's an 19, no? Everyone follow me? Are you boring?
Yes.
You're boring?
No, I'm following.
Oh, okay.
No, we get it.
No, you are boring.
Again is
No,
are you tired? Are you tired? Suppose the worst scenario. Okay, we don't finish today. Okay. Don't worry. I will send the test. And you are doing the part you know. According to this. We cover every theoretical part and we practice a lot. But I need to, the review is reinforced. But don't worry. I sent the test. You start working on the test. And next Tuesday, we continue this package. And the due date for the, I suppose que Thursday. I don't know. Depende. Okay, entonces, okay, I copy 48 y cubic plus 81. What should I do? I'm confused in this problem. GCF. We have GCF or no? Okay, I have no idea. 48. When you have no idea, you in one corner of the piece of paper, you break it down 48 and prime factorization. 24, 12, and 6, 2, and 3. Okay. And 81 is not divisible by 2, but it's divisible by 3. I can see clear now. What is the GCF? What is the GCF? 3 is the GCF. 1, 3. Guys, there are system. I explain everything in detail. The systematic way to find everything. It's no, look in the ceiling. No, you copy that, break it down, and you see what is the common factor. Entonces, si 3 factorado stay decomposition. Decomposition. Stay 16, no? 1, 2, 3, and 4, 2, que es 16. 16y cubic es 16.
Acho que 4
A ver, ¿es igual o no? Ok, 48. 16y cubic plus 27, no? Plus 27. Plus 27. Well, in this case, okay. Leave it like that. Leave it like that. Why leave it like that? Because you can suppose that this is a sum of cubic, but 16 have no perfect cubic. It's decimal. A ver, I did well or I did wrong? Okay, no. Sometimes happen. Sometimes,
Right.
Sometimes you don't expect happy end. Maybe the majority of the problem I present to you have happy end because it's intentionally I create happy end, but in this case, no happy end. And leave it like that. So the only possibility we can do that in this stupid problem was GCF and end the story. Okay, not always happen, but sometimes happen. Okay. We have 10 minutes more. Okay, 21 is super easy. 21 is super easy. 21 is cx squared minus cy squared plus d x squared minus d y squared. What technique you apply? GCF, grouping, trinomial, binomial, what do you think?
Grouping.
Grouping. It's obvious because it's 4. So when there's 4 terms, yeah, immediately. Well, not always, because we see there's 4 terms, but we have GCF, but we have no GCF in the entire expression. We have GCF by couple. What is the GCF in the first couple? C. What is the GCF in the second? D. Yeah, I can see that x squared minus y squared is common factor, entonces we have c plus d. I finished? No, because we have here a difference of a square. It's xx, yy, plus or minus, c plus d. End the story. This is the final answer.
Professor, I have a question.
Go ahead.
We have we need to break down. We do not need say like the third part.
Wow. Noela, I don't understand anything. Try to explain again.
Okay, so in the test, if you have a different of we cannot live like that. I break step.
Well, okay. I understand now. Okay. The question say factor completed. Suppose that you factor out 12. And you say the answer, professor, is 3 and 4. You factor complete? No. Why no? Because you break it down 4 and 2 and 2. So the total factorization of 12 is 3 times 2 times 2. So you cannot leave it like that, because I suppose that you realize that here we have a difference of a square and you need to continue one extra step. Clear?
Yes, Professor.
Okay, 22 is a little bit weird problem. It's a squared minus 2i is a plus 1 minus 9. Entonces, give me a hint. Group the first 3 terms, okay? Normally, this is no situation can happen, but bueno, okay, I obey the order. So they want you condensing this in only one. Entonces this is perfect square trinomial, and the factorization is a minus 1 squared. Make sense, right? Because square root is a Square root is 1, multiplication both, extra 2. We have 2a, perfect. And this is minus 9. Oh, and leave it like that? No, because you continue factorization, because I can see here a difference of a square. And you can see here a difference of a square. The factorization is 2 parentheses, a minus 1, you consider it like a one package, and 3, and plus and minus. And that's it. No, you condense it. A plus 2, with negative 1 plus 3, and a minus 4. End the story. It's a one we are frequently, we don't do in that way. We are doing different way. We are doing another way. Maybe we are doing in that way. Look, a squared minus twice a, and you condensing this and this minus a. Okay, 1 minus 9 is a. Now you factorization like a regular trinomial. A, 4 and 2, because 4 times 2 is a, and 4 minus 2 is 2, negative 4 and positive 2. And we get exactly the same answer. Okay, I respect it. 23. 14, a squared plus 14. This is a stupid problem. Okay, GCF. What is the GCF in that case? And 14. You factor out 14, a squared plus 1. We can continue or no? A squared plus 1 is factorable expression or no? No. So this is the final answer. Because it's a sum of a square. Clear or confusing? Good. 24. 24. Guy, I spent a lot of time to explain to you factorization chapter. I suppose you remember in your entire life factorization, because we are using in the next mathematics you need to take color algebra or pre-calculus or calculus, factorization. Okay, we have GCF in this problem. Is trinomial?
No.
No GCF. 1. What is the trinomial? What kind of trinomial? What kind? Regular, complicated, or perfect square?
Complicated.
Complicated, of course. And your multiplication is 24, and I try to find the key to open the door. 2 factor of 24 que somehow give me 10. Well. In this example, we have 2 combinations.
6 and 4.
10 and...
Is it 12 and 2?
Es 10 and 2. No, 10 and 2, no. 12 and 2. 12 and 2. I agree. 12 and 2. And 6 and 4, no?
Yes.
Yeah. However, I know very well that only one combination open the door. And you need to select one. When you select one and you try your best by grouping and doesn't work because I am sad, when you get 2 completely different binomials, entonces I discard this option. What do you recommend me? 6 and 4 or 12 and 2?
6 and 4.
6 and 4. Nuela recommend me 6 and 4. Let's see si Nuela has right or wrong. Es minus 6xy. Remember, I copy only the same variable, no? Minus 4xy, minus 3. And I'm doing well or wrong? Okay, another possibility is, let me try. X squared, y squared. Es 12, entonces plus 12, plus no, minus 12 xy plus 2xy minus 3. Do you see the 2 possibilities we have? Now, looking at that, what do you consider the correct and the incorrect?
We need to try grouping.
We need to try, okay. We need to try. Okay. Let's try. GCF in the first couple. GCF in the second couple. GCF in the first couple is 2xy, correct? 4xy minus 3. And the GCF here is minus 1. 4xy plus 3. The mine is good, no, the mine is bad. Because 4xy minus 3 is not equal. Okay, this is good. Look, no, it's okay. Okay. Let me try the second. The second is this is again 2xy. No, sorry. F4 xy. We have 2xy minus 3. Oh, and this is identical. 2xy minus 3. I suppose que the GCF is 1. So it's 2xy minus 3. Open the last parenthesis, 4xy plus 1. Beautiful example. Final answer. The combination of word was 12 and 2 because 6 and 4. Unfortunately, it's wrong. Okay, guys, stop. I want to say now, if you want waiting for me, the test 3 on paper, I need to create the email. Okay. Wait for me. I need to create the email. First of all, I need to find the test. Okay, I suppose it's this. Let me check it just in case I attach. Yes, it's this. Now I copy and paste your email address for everyone. Mark 1105 class. Select all students. Copy. Yeah. MAT1033, yes. Paste email address. Control B. And send to you now. Oh, I forgot something. I forgot the subject. The subject say test number 3. Is due March 23rd. Okay? Tentative. I don't know if we finish or no. Okay, I sent. Let me know if you receive and you got it. You can leave.
Professor, we didn't finish the package.
Say again?
We didn't finish the package.
What package? This package I sent to you. If you want, I send again to you. Noela, please email me now and I reply you with the information for the package. Okay?
Okay, thank you.
Let me know if you received the test number 4.
Yes, I received test number 3.
Okay, good. So you can leave.